Hello and welcome to today's session in the Power webinar series. This is Jyoti Dodia, and I just wanted to welcome you to 2019 and the sessions that we're going to be having on this series this year. So first of all, I'd like to really thank everyone for the feedback that you provided for the previous year's sessions. I was truly amazed by all the positive and also the lengths that people went to in terms of the amount of comments and suggestions. So thank you very much. We ran about 11 sessions last year and hope to continue around monthly sessions for this year too. So I'm very pleased to have Nigel Griffiths back with us today, and he's going to be covering NJMON in all its glory. So without further ado, over to you, Nigel.
Thank you very much, Jyoti. I hope you can all hear me. I'm famous for Mr. NMON. I invented NMON 22 years ago, I think now. And we've been a very successful program. We can see things on a cursor-based application on AIX and Linux and the VO servers. And then a lot of people are saving the data to a file and then analyzing the graphs we can generate later on. And I've been looking at where would I want to take NMON, how we're going to extend it, and it's actually pretty difficult to start with NMON and go forward. It's a little bit stuck, if you like, in its the way it operates and the way it handles data. So then we looked at, sat back a bit further and what we'd actually want for the next generation of NMON, and here we have NJMON, and the J in there is for that it generates JSON format data rather than its own, and we'll have a look at that in a minute. Okay, Jyoti will probably have to say this 20 different times in the chat, but the slides and video replay and any questions that get asked will be on the website for the Power Virtual User Group later on today. Now, if you're new to NMON, then we can quickly get you up to speed on YouTube. My channel is Nigel A.R. Griffiths, and there's about an hour's worth there for Linux and about an hour there for AIX. You notice the NMON chart is in both of those, but that will get you started running them on the screen or saving the data. And on the AIX one there, we can use the analyzer to look at that data. You can actually use the analyzer too for the Linux data, although the Linux guys don't like running a lot of Excel, is my experience. They'd rather not do that if they can avoid it. So there's a little bit of crosstalk there between the two different flavors of them. And the button didn't work, so let's try again. There we go. Right, so NMON became part of AIX 11 years ago, 11 and a bit, or 10 and a bit. And it's now part of the AIX source code, proprietary source code, so you can't get the hang of that. But it is 100% supported if you paid for your AIX support. Also, we have the NMON for Linux, completely different source code. Okay, it's got a big loop in it, and it outputs some stats either on the screen or into a file, but the rest of it's different because the places that you get the data from is completely different in Linux. In AIX, we have something called the libperstat library that provides it in a perfect way that a C programmer wants it. In Linux, we have to open files and guess what format they're using today, and try and get the stats out of those. The NMON for Linux is open source, so you can go and download it, a couple of thousand lines of code, all very simple C code, as long as you understand pointers and all that. Bigger problem is because Linux runs, there's lots of different distros and versions, and they change them as they go. And also that Linux runs on lots of different hardware, doesn't it? My home ground is on the Power machines. I've got a couple of Power 9 machines now. A lot of people are using it on the Intel AMD or the x86-64, which is a bit of a mouthful. Also runs very nicely on an ARM. Raspberry Pi is what I mean by when I'm talking about that. I run Ubuntu on Raspberry Pi, and Raspbian also supports NMON. And we have Linux on the mainframes as well, or the Z products, what I'm going to call them these days. Mainframers tend to run mostly SUSE slayers on their machines. I don't know if That's important or not, just an observation really. So the Linux world is a bit more complicated because we have to compile it for different processors than the different distributions as well. There's some subtle differences about where the files are on the distributions that we try and work around. Okay, so on the left-hand side we have the NMON analyzer. You move the file to your laptop, whatever you're running there. You're probably running Excel, and the analyzer as an Excel spreadsheet with lots of Visual Basic in there, and it generates all the graphs for you. So that's the way we work, and that's mode. Somewhat old-fashioned, really. Collecting files, moving them to your laptop, and chunking, putting them through Excel to grab the graphs. A little bit more automated is this NMON Chart. Because we had problems with the analyzer and some people just don't want to run Excel, I thought, well, let's try and do a sort of Web 2.0 version. So it's actually a shell script, Corn shell script. I've been told it runs with Bash as well. And a lot of systems admin guys could hack a bit of shell script if they wanted to make a change or add a graph. So that's more available, if you like, than going off and learning Visual Basic. So now we've got something that's actually running on a Unix or a Linux computer. We can take hundreds of NMON files, run them through the NMON chart filter, and that converts the NMON file into a .html. That's a web page. It has lots of JavaScript arrays for the data, and then it calls on the Google Chart library to actually display those in your browser. But you can automate these and do them a lot quicker than you can with Excel. In fact, if the NMON file is too large and you put it into Excel, it will slowly grind your laptop down to a halt in 20 minutes, so then you have to take the battery out to try and reboot the machine. I know, I've been there, but the NMON chart can handle much, much bigger files when people are collecting thousands of data points. Okay, this is what NMON chart looks like. Just a reminder, if you haven't seen it before, the graphs I think are more interesting and beautiful. On the top right, we can see the virtual processor numbers, the orange at the top, and the actual CPU used is going across the entitlement barrier during the day. On the top right, we have a bowl chart which has 3 dimensions. We have CPU across the bottom, up the side is the amount of I/O it's doing, and the size of the blob is how much memory it's using. So on the far right, you can see Oracle. That's the big gorilla on the computer, taking lots of CPU, lots of I/O, and lots of memory, which is that's its job to do that, isn't it? And we've got other graphs in there. The bottom right one is networks, where we split out the reading and writing, and we can see patterns between small SQL coming in and great big megabytes of data going out, or the backup kicking off at 3 o'clock in the morning and things like that. Okay, well, that's enough talking about the good old NMON, and I need to highlight the fact that NMON is not going away. It is very good at what it does, but as a vehicle of moving forward, it's getting pretty tricky. One of the big problems is, I'll come to it in a minute, but is that if I change the NMON file format, it upsets all the tools downstream that take those sort of files. If I add an extra column, then a lot of graphs will go wrong, or the columns will be going wrong on the graphs, and all sorts of horrible things happen. So it's a bit sort of locked down because a lot of people are relying on it. So the J there is about JSON format files. I'll give you a tiny little snippet of a JSON file so you know what that's about. Now, it's odd that my son's name is Jason. It caused a bit of confusion around the house here. And the next project's got to be called NHMON, because my daughter's called Haley, and she got a bit upset that it wasn't her letter in the name. Okay, let's move on. So I mentioned already NMON, 2 modes, 99, maybe 99% of people are collecting the data on every machine, every AX and Linux, and saving those. And if there's a problem, then they go and actually graph those and have a look. Some people have actually got a problem right now. You can use the NMON on the screen to actually investigate what's actually gone wrong now, and can we fix it while it's live, rather than waiting for the end of the day and then looking at a graph. I'll cover the 2 analyzer and the charter. So NMON's very good at what it is, not going away, but there are some limitations. It has a limited number of stats. Remember, we started 22 years ago. Machines were small, 25 megahertz. I think it was 16 megabytes of memory. You can put another 3 zeros on the end of these numbers, we couldn't save the nmon stats across the network because that would cripple the performance of my benchmark. So we actually limited it down to a core set or something, things that we knew exactly what they meant and could give us clues about how we could performance tune our workload to get better performance in the benchmark. It wasn't for capacity planning or for the global grab every number we can off the machine. And we tried to keep it below 2% of the CPU time as well. That's got even better with faster processors these days. When I was writing the NMON chart, I suddenly realized how quirky the comma-separated values file was. And it was quite a technical challenge trying to get some of the data out in the quickest possible way. I had to use my right-hand man in my team, Gareth Coates, and set him some challenges. Right then, Gareth, if it looked like this, but I want to look like that, how can I do that quickly in a shell script? And he'd usually come back with an answer in half an hour. Also, in those two tools, the graphs are a bit static, aren't they? They've been set up. If that's exactly what you want, you're okay. But if you wanted to look at a different number, or you wanted to look at it in a different way, or even just change the colors, it's very difficult to do that unless you start hacking in with the code. We also have a data storage management issue. nmon can generate a lot of data from a lot of machines. On very busy machines, and you're collecting the data fast, you could create a terabyte of data a month. If you've got a few hundred machines and each of those has got 10 LPARs on it, it does ramp up. And people say, I can't manage all this data, Nigel. What am I going to do? And the answer is, it's not my problem. Is it really? I'm there to generate the data. You should handle it. Particularly if you're doing capacity planning, so as well as lots of files, you actually got lots of history, and that is difficult to manage, and people are hand-cranking solutions for that. And also, the nmon doesn't have any real-time graphs. Now we have some little graphs on screen, little hash symbols go up and down the screen, for example. But if you wanted to change, look what happened last week, then we don't have tools that could do that for you unless you've implemented something yourself. So with NJMON, we've only got one mode. It saves the data. About 10 times the number of stats. The Linux people tend to change the stats in different files. I got somebody raising bugs now that one of the stats we were tracking has disappeared, and they've got two new ones, which just sort of look the same. So we're trying to grab everything we can off both AIX and Linux, JSON format. Now here's a quick dodge. Python can read JSON format data very fast, and we'll come back to that in a minute. Once we got to JSON format, this is sort of industry standard for stats. The other one would be XML, but that's really ugly, and it repeats itself. Whenever you have a header line, then you have a backslash in the same header content to tell you which bit is trying to finish, so we don't have that in JSON. And if we got JSON data, we can pump that into a time series database. That does all the data management for us. It can also do consolidating of information if it's too fine-grained for the longer term. And then we can pull out that data in real time. So we can say, what happened in the last hour, what happened in the last month? And with the graphing tools can tell you instantaneously, change the graph and tell you compare it to the previous peak of the month to see what's going on. I've also created a NMON chart, NJMON chart rather. Rather than shell, this is in Python because it's JSON data, and I've got the first 24 graphs done. I'm going to give you a little show of that. So you run NJMON, collect the data, inject that into a real-time database. Then we've got various ways of getting it from NJMON to the database. About 6 different ways of doing that, depending on what you want to do. And then we got go to the browser to a graphing engine, and we can have these things called templates. So this is a set of graphs, and then we can apply the template for different machines and see what's going on in our computer room. The ones that I'm using also have alerts, so you can say if the CPU goes over, the user and system goes over 90% for 5 minutes, then it starts doing things, flashing things on the screen, or sending an email, for example. So you're getting some alerts where the monitoring tools are saying, hang on, you need to have a look at this bit. Right, so I'm going to give you, now rather than talk for an hour and a half and then give you 5 minutes of what you're going to get at the end of the day, I thought I'd give you a little taster of what we're trying to aim at, and then you'll be more interested in sitting through the rest of the presentation. So, we're going to share an application here, which is Google Chrome, and Jyoti will confirm that she can see it. How are we doing?
I can see it, Nigel, and just a reminder to people, if you have questions, can you please post them into the chat window? Please specify what topic, because we'll be taking them towards the end of the session. Thank you.
Okay, so here's an example. This is InfluxDB and Grafana running in here. So I've got a machine called Silver 5 running in here. So we've got CPU utilizations. We've got the time in here. It's universal time coordinated, or UTC. That's also known as Greenwich Mean Time. And I just want to point out the fact that I can look out the window and see Greenwich, because the English invented time. And then we've got some details in here. Here's a static one fact things in here. This is the current value for the VP entitlement, SMT, and memory on this machine. We've got pie charts in here, and if I grab the little edge in here, I can pull this down. So we've got run queues. We've got the gigahertz ratings in here of the nominal gigahertz and the actual. You can see that I'm running at 3.9 gigahertz. This is a Power 9 machine, and lots of other things in here. CPU consumed, system calls, other bits and pieces, and we can just slide down. This is my selection of graphs that I wanted to work at and show off some of the capabilities. So we've got network graphs down the bottom in here. Let's slide back up to the top. We can actually, this is a machine called Silver 5. I can select another machine. I'm only going to go to one I practiced with earlier, Brass 6. So this is a different machine now, and so the graphs have all changed and telling me the configuration of this machine, and my pie charts are working up in here. We talked about looking at different timescales. This is looking at today, I think, or the past 12 hours. I can go back and say, let's look at the last 7 days. There's a great big gap in here because on Friday, Gareth and I upgraded the firmware and I forgot to restart NMON on these machines. So there's a big gap in the middle, a bit of a lesson here. But if you wanted to look at a particular range, you can mark it up and zoom in and have a look at the data. If you look at this red line here, it's telling me the data and what the numbers are. So, and if I hover over a particular number, that one you can see weight is 11%. That's the one we're actually hovering over at the moment at the top of the graph. And the system is 3%, or whatever you want to like in here. And this is all immediately changeable. So if I said, well, I want to actually see that in more details, I could just make the graph bigger. Look at that. Oh dear, Excel, hard luck. And there's other tools in, like this is Grafana, but there's lots of other tools that can make to these sorts of changes as well. I can also go up here and add a graph, like a regular graph in here. It actually throws random data. I hope that's the share price of IBM going up there, but I think it's completely random. And we'll look at how to create these graphs later on in the second or third demonstration. Now, I've actually, if you click this is the logo for Grafana, if I go down in here, you can see I'm the admin user in here, so it's like the super user. Got various things in here. If we go in here, we can create a new dashboard, and we'll do that in a later demo as well. In here, here's the alerts, and there's lots of configuration stuff. The data sources, as far as Grafana is concerned, is things like the InfluxDB, or it could be an SQL engine, or Prometheus, or Graphite, and lots of other different databases that collect these sort of stats. Okay, just got my list done here. I covered that, and yeah, we can do some interesting things. It's very difficult to write a book about a graphical user interface, isn't it? And you suddenly learn some things. I spent an hour trying to work out. Look, we've got this orange in here. This is free memory. Well, that doesn't look right, does it? Look, we've got system down here in blue, and we got system over here in red. So I don't want to change the color of these things. How do I actually do that? And I went to go look at a video, and eventually it says, oh, it's so obvious. You can't believe it. But then you have some really tricky problems, don't you? What is the color of free memory? I was thinking free, freedom, grassy fields and the wide open outback. So anyway, what you do is you just click on the color, and it says, what color would you like today? Look at that. Isn't that cool? Anyway, I get excited about these sorts of things. So yeah, this was the admin user. This is what's called known as a dark look and feel. If you're in a darkened room, this is pretty nice. You'll notice that some of the numbers get cut off in here. Because I'm running out of screen space. That should improve that. I've got another one in here. I've logged in as myself. If I look in here, down here, this is me. And this is the light format. Now, if you're in a bright room, then the white colors are a bit better. But you can go change them for particular users. At the moment, this is doing it in real time. I'm collecting data once a minute, which is fairly slow. In here, you can say get back up to date, but these graphs will move over once a minute as the data comes in, and you have a little timeout thing. You say if you don't do anything on the user interface, then it'll actually slow down the updates to the screen to slower and slower to not waste CPU power on your laptop in here. Okay, so now we're going to try and go back to my screen 2. Did that work, Jyoti? Can't hear you, Jyoti.
Yes, it did. We're back at the demonstration 1 intro to the GUI.
Yes, thank you.
Okay, great. Let's carry on then. So I've captured a couple of the screens in here to remind you what to look at. Yeah, and you've got the pop-ups here, so you can actually find the real number underlying it. And we're going to see some of that later on. Right, JSON format. On the left-hand side, this is just a JSON file. I'm just looking at the format. Strictly speaking, JSON can go in with no space around things and no line feeds even. You can just go as a blob into a file, but most people try and make them look good. For the JSON that I'm generating, they will actually look nice if you go and edit them, unless you go and go and have a look very quickly. But in here we've got example of, you have these different various labels or whatever you like between double quotes. But then you have strings, or a list of characters, integers, floating point numbers, and true. Now, over on the right-hand side, Python has a dictionary, a data type called a dictionary, and it looks remarkably similar, doesn't it? There's one subtle difference between the two of them, and that is that in Python, the true has to start with a capital T. So it's fairly quick to work around those, but it means that if you've got a big JSON file, you can absorb that file very quickly in Python. So in our case, I'm generating the graphs that we're looking at. That's creating 40 megabytes a day, and Python can read the 40 megabytes in, scan through it, pulling out all that data that I used for the NJMON Chart tool, generate the output file. So 40 megabytes in, it takes less than a second to actually generate the web page with all the data in it. It's really, really quick. And we can then handle much, much bigger files if we want to. So this is why you find me talking about Python and using Python to handle JSON files, because it's extremely fast and extremely easy to actually do. So if we look at the left-hand side now, this is like the first block in here is, strictly speaking, well, actually, this is actually a list of JSON objects we actually have now. You'll see the comma and then the next curly brackets at the bottom. This will be the next snapshot for NMON data, for example. In Python, it's as a C programmer, it's a bit spooky. You can type in D or whatever the variable is called, equals, and type in a JSON structure, and it says, yes, okay, I know what to do with that, I understand that, and I can deal with that very quickly. And if you wanted to print out, for example, the 1, 2, 3, 4, 5, 6, then you use the print function, and you say D, and then you give it the label you want to, and it will pick out the 1, 2, 3, 4, 5, 6 for you and put it on the screen for you. So it's very natural in Python to actually pick out what you want. Typically, you go, so for a sample in a list of samples, and it gives you one at a time, and then as each of those comes up, then you can do the manipulation of pulling out the data you want and outputting it into the file for you. Okay, this is a little bit sidetracked in here. Chrome and Firefox understand JSON files, so if you just open a JSON file, it actually understands the contents of it, and you've got these little twisties in here for the different JSON records, if you like, in here with the content over here. It's very nice. And if you're using Vim, which is the VI editor on Linux, it too can do the syntax highlighting of a JSON file, which really helps you if you're creating a file and you're missing a double quote somewhere. It will instantaneously tell you where you made a mistake and where you got to go and fix your code. There are lots of tools out there that can handle JSON format. I can't help thinking that some people might just pump these JSON files straight to a website that's got sort of Java hanging off the back end and do the direct manipulation of all the data and saving it into databases themselves and graphing it. But I'm looking at more some up-to-date tooling that's already built, and you can just pull the download and start using them. So if you've already got one of these tools, or another one that's not on this list, these are just ones I've investigated, then carry on. I'm not trying to kill off your tools that you're familiar with. So I'm using actually InfluxDB and Grafana. So InfluxDB is the time series database that I inject the JSON into, and then Grafana we've seen as a tool that can connect to InfluxDB and pull the data out and graph it for us. Another famous one is ELK, which is the from a company that has 3 parts are built into like an application. Again, it's open source, but it's called Elasticsearch, Logstash, and Kibana. So the Logstash is taking the data. The Elasticsearch allows you to look at the data and particularly formats of log files. So you can investigate, syslog, for example, and tell, the first thing is the date time string, and then the second thing is what the data name is, and the third thing is the value. And then ELK says, okay, I understand that file. And when you say, right, now I want the CPU utilization numbers, then it knows which bit of the file you're actually wanting, and then it can find the data for you. And the Kibana will then graph it for you. Splunk is another well-known one. It's been around a bit longer, perhaps. Splunk doesn't have these various parts. It is Splunk. So you start up the console, and in the console you can find your files, and you can explore the log files and express how it would want to name the various parts of various files. And then it's got the graphing tool built into Splunk itself. Prometheus is out there as well. I've had some problems with it. Prometheus doesn't like doesn't like JSON file formats, really. Its mode of operation is you have Prometheus sitting as your central server, and it polls these things called node exporters on your machines. So you're on a node exporter. It contacts the node exporter at a regular interval that you've told it to, and it pulls the data, the current stats, out of the node exporter. Now I'm generating NMON data. That's not. I'm trying to push into the database, and this is the database pulling data, so it doesn't really match very well. We may be able to get in the NJMON JSON data and stick it through a converter so it's in Prometheus format, and then it can take it as a text file and pump the difference of the file up to Prometheus. But it doesn't really understand that the JSON file might be 10 snapshots over 10 minutes. It will just say, no, this is the time I got the data. This is the time that the data has. So then it's all getting a little bit tricky. So we'll see that we can work with Prometheus a different way. There's lots more tools out there. I'm not trying to tell you what to do. That's up to you. Right, so they all have some sort of data gathering agent or agents. All have a stats database. Many handle these odd format log files or whatever it was. You can do an analysis on that and get the right data out of it. And then they have a graphing engine on the back. And they all tend to work in 3 modes. There's an open source project that you can just download. And sometimes they have optional support for that. You can just pay for the support. Or what I think they're more keen if you take in is the enterprise version, which has the open source content, and then it has extra facilities like full support. It has HA, what happens if the machine your database is on goes down. Well, it can have a backup database, and it's scaling for large scale. You've got 10,000 servers. The open source one may struggle with that, and it's got backup and restore features built into it as well. I haven't bothered with any of those enterprise type features. I'm just trying to get some nice graphs working for me at the moment. And they all then offer, if you don't want to install it on your machine to run it, you can run it as a cloud hosted service. So instead of pumping the data to your database, you can pump it into the cloud, and then you just log in and you get access to the data on cloud-hosted machines. Now, the choice is completely up to you. Of course, if I ask my manager for £10,000 for a new tool, he would just laugh. So I'm going for the open source at the moment, but the choice is yours and the associated costs. Now, I can't boil the ocean. I can't install, manage, test, document 4 different time series databases and 4 different graphing engines. I just don't have the time because NMON and NJMON are not my full-time job. I do it largely in my own time, although my manager is generous in January because they're reorganizing the sales team as normal. Anyway, moving on. So I chose open source, cheap, easy to install and run. InfluxDB and Grafana. I'll come on to that in a minute. Very easy to get going. It is popular, this combination, and highly rated on the web. The IBMers in MOP, that's Montpellier in the south of France, is a big benchmark center in Europe. They recommended this as a good place to start as well. And one of the things I wanted, because I want Python to read the JSON files, we have a Python module that knows how to log onto InfluxDB, and then you can just pump the data as records into the database. Other ones do. Elk has a Python module, for example, and Splunk does. I played with a Splunk. I got it all up and running, the free version of it, and set it up, but something wouldn't quite work. I couldn't get the data in. And so I talked to some of the Splunk guys, and they turned out to be ex-IBMers. I knew half the names. And they said, well, we'll just let you log onto one of ours on the web. So within 10 minutes, they got me access to it, and then I spent 4 hours pumping up data into their microservice on the web. And I said, okay, I kept it fairly busy for the past 4 hours, and they said, not off. It was knackered because I was pumping the data up so quickly, and then I could want to then experiment with some graphing with that. Okay, now let's move on. Now, it turns out that all these tools all have a sort of interrelationship. Splunk is over by itself as a separate tool and quite highly regarded. InfluxDB, in the middle left, actually comes from a company called InfluxData. They actually create the open source tools. So I'm using one of their tools. They have Chronograph, which is their graphical user interface to generate the graphs, and their data collector is called Telegraph. There's a sort of set there. I'm just using InfluxDB. And connecting it to Grafana. Now, Grafana has a good reputation for being very flexible and easy and get you started very quickly, so that's why I'm using it. But I could use Chronograph with it. Now, Grafana can take data from all sorts of places, including the purple at the top right log stash log search. There's Graphite out there as well. Graphite and Grafana have a sort of semi-relationship as well. And then we have Prometheus down in here. If you put some of the data into Prometheus, then Grafana can read that in. So you may, at the bottom, use NJMON may go into InfluxDB, and then use Node Explorer to get data into Prometheus, and then you can use Grafana to look at both sets of data and draw graphs showing you what's happening at the same time. Just out of interest, in the middle bottom, I have nmon down there, and we have nmon to InfluxDB. So the converter that will take nmon file, it is limited, but it will put that data into InfluxDB. So you could have NJMON data for your latest, newest machines if you set that up, and then some of the older data you could look at via the nmon to InfluxDB. Okay, there's some other things. I don't know what CloudWatch is. It's probably some sort of googly type cloud offering, and it can talk to relational databases, MySQL and PostgreSQL, just standard Linux style open source databases you might be using already, and you can put the data into those. Although, of course, we want to use Python to read the JSON data. I'm not sure if there's a Python module to squirt it into Ingress QL, for example, but that's up to you if you want to do that. Right, now all of these tools tend to assume you're using Linux on x86-64 or ARM, Raspberry Pi. Some of them have an ARM code that they have that you download. Now for the power guys, Linux is okay, we can do that. Intel is not acceptable. For my example, I have 2 little old 8-year-old Intel boxes running at 2.4 gigahertz that I have been using initially. But I've got some massive great power boxes with plenty of horsepower and bandwidth and disks. that I'd much rather use. But there's, at the moment, the websites don't have a download compiled for the Power processor. So obviously that needs fixing. Now the InfluxDB I've compiled once I found the instructions. InfluxDB is written in Go or Golang, so you have to get that working first on Linux on Power. I'm using Ubuntu on Power, but it's equally available for Red Hat and SUSE, for example. And once you've got Go working, then it's a fairly easy way of getting InfluxDB compiled, and you end up with a binary. I haven't gone to the next step, which actually creates a installable package, because I can just copy the two binaries. There's one is the actual database that's daemon that sits in the back, and there's one that you could use to connect to it to write commands. So they're available. So I need to finish that. I haven't tried yet with Grafana. I ran out of time. I'm pretty sure that's another Go language tool in there, and we can get that running on Linux on Power. AIX on Power might be a bit more of a struggle, because a lot of these tools you have to pull in another 10 or 15 other open source packages that we'll have to make sure are available on AIX. But Ubuntu, Red Hat, SUSE on Power, that's good enough for me to run it on my beloved Power processors. Right, FUD reduction. What I'm worried about is now you're thinking, oh, this all sounds very complicated. It's going to take hours or days, and I haven't got the time to do that. Now, it's very easy to install that on your Intel AMDs, and even on a Raspberry Pi. I'd say a Raspberry Pi B, because it's got a faster processor and a bit more memory. But again, it's a very fast install onto a Raspberry Pi. So if you haven't got a spare machine, most people are going to fund a $35 Raspberry Pi, and you could run all your experiments on that. Okay. So when I was trying to work out how to tell you how to do all this, I suddenly found this guy, bottom left. Well, the name of the person updating YouTube for these videos is called Tips for IT Pros. It sounds all right, but I'd like to know the guy's name, really. And he's got a 6-minute video that installs InfluxDB and Grafana on an Intel machine. Fair enough, okay. He actually uses, it says in red there, Ubuntu, and he actually installs the InfluxDB from the Ubuntu repository, which is rather an old 1.1 version. I mean, that means it's like nearly a year old. They're up to 1.7 something, 3 or 4 now. And so I just got the copy from the InfluxDB data website to download, and you download it from there. But apart from that, that's a 6 minutes to install both of them once you've got, in this case, Ubuntu, but other Linuxes will do just as well. So I'm not going to go through this in great detail in here. I pulled the code from here, portal.influxdata.com downloads. You can see in here it supports, got a list Docker, Ubuntu, Debian, Red Hat, CentOS. SUSE wasn't down there. It supports Mac OS X, whatever that is, and Windows, for goodness sake. Okay, you can take your pick. Get the time zone and date correct on your machine, because you want the graphs synchronized, right? Update the operating system. And there's a sudo command to do that, and get email working. The Grafana will controls its users by sending them email, and so you need email working. And then literally wget the Debian file, and then you do the package to install, and 2 minutes later it's done. You type in influx, that's the console, if you like, to the back-end daemon. It's got a D on the end. And you say create database, nmon. It's just got to have some name. You can choose to have show databases, and it says yes, I've got an internal database that we don't ever touch, and we have the new nmon database there, and we exit. That's it. It's done. It's about 2 minutes work. Right, moving on. Grafana. Okay, I'm assuming that you're installing this on the same machine as InfluxDB, and when I'm running, I've got about a dozen machines putting data into them and sitting there graphing things all day long. On an Intel machine, and it's like 2% busy. It's got 4 or 5 CPUs in it. Very low actual work that it's generating, so makes it sense to have them on both. So wget to get there, add the package. There we go. There is a grafana.ini file. All the defaults work for me. Didn't change a thing. Then you're going to set up the system control so that it starts every time you reboot your server. Right, the next bit is joining Grafana to InfluxDB as a data source. So we'll just go onto that. So we log into Grafana, quite a nice screen, really, as admin. It says that's a dumb password, and you've got to change the password, so whatever it is. Then you go into the Grafana homepage. It's actually taking you across install Grafana, add data sources, create a dashboard, create other users, and install applications or plugins to do some more fancy things. So we're at the data source in here, and it gives you install Grafana, which is what you want to do. We've done that. Then we're going to add a data source, and then that's the list of things I read across here. Okay, carry on. Next screen. In here, it says what is your data source. It gives you a little picture. So it's InfluxDB, and it's got the other ones listed up in here. This bit confused me a little bit because in the URL it's grayed out. It says HTTP localhost 8060. And if it's the local machine, that's what you need to type into that box. It's not actually there. It's sort of grayed out as a reminder of what it wants in this box. So it's InfluxDB, and where it actually is, the database, which in my case was NJMON, and the user and password to get into InfluxDB. Okay, moving on. Now you're ready to create a dashboard, but hold on, you've got to have some data, and I recommend, don't now start collecting the data. Start the NJMON running yesterday, and then you've got a day's worth of data that you can actually have a look at. Okay. So this is the NJMON CLI, command line interface. And so there's various 1, 2, 3, 4, 5 ways of running that. If you just run NJMON, it will blast all the JSON at you on the screen. Default to standard output. You can redirect it to a file if that's what you want. Another way of doing it is you say -m directory and -f, then it will generate a file name which is hostname, date, then a capital T and time. This is the actual ISO standard for a way of writing a time that it uses, and it creates a JSON file. Another way you can run it is run the NJMON and then pipe it into an injector PY. The PY means it's a Python script, so this is what I'll supply for InfluxDB and Splunk. Haven't had a go for Elk yet. It's going to be a sort of similar sort of deal. But you can then capture the data and immediately inject it straight into the database, so you don't have to, make a physical copy of the JSON data on your disks or anything like that. Another way you could actually run it is if you have the JSON file, you can run the injector and pipe into or redirect the standard input into it of the JSON file, and it will just inject that file straight away on the spot. Right, the other way of doing it, I wanted to make this more easy for setting up hundreds of machines. So the first one is you go to your time series database, InfluxDB in my case, and then I've set up SSH so I can log onto the other server where they want a target for collecting the data. So I'll log onto a machine, run NJMON there with whatever parameters I want in here. That's very slow, it's every 5 minutes. But anyway, and then I can pipe the output coming out of the NJMON straight into my injector. So that again doesn't create any temporary data, just puts it straight into the database. Then people are saying, hang on, pal, that's a lot of work setting up SSH and all these things. I'm not sure I could do that in my computer room. So we have what's now called a collector. So on the time series database machine, you run the collector here in green, and you say what port you want it to open, sort of classic 8181. What directory you want it to run in, that's where it will actually save the files. -X, this is a like a password, I guess, or secret fact or something in here. I'll just put Beetlejuice in here. -I says when you actually get the data, save it to a file, but also inject it straight into the database. And the -C allows you to change different injectors. You might want some machines injecting into, production database, and some machines putting the data into a different database within the InfluxDB or the time series database. And then when you're actually running NJMON on your nodes, your LPARs or virtual machines, then you use the -I and tell it which machine to send it to, give it an ID of the port and the secret, and then it will open a socket to the time series database machine, send it to the collector. The collector will make a copy in the local file system, and it will automatically inject it if you ask for it. Okay, hopefully that makes it rolling out in NJMON a lot easier than it might have been in the past. With nmon, everybody tends to collect it locally, and then they got to FTP it or whatever to get the data to the central site. Now, under the covers, if you're a bit of a programmer, don't be scared. Neither of these bits of code are very big. NJMON for Linux, pretty simple code, plods from top to bottom and goes around a big loop. I've got a set of P functions like P string, P long, and P double. This actually adds the different data types into the data structure, and P section gives you the section header for the JSON, like CPU, memory, disks, and things like that. In Linux, the stats are all over the place, loads of it in /proc. Every file has a different format, drives me nuts. And then sometimes we have to go and run a command to get the data out. So we like lscpu, some fascinating details. We capture those and put it into the JSON file. We haven't yet added the process stats, details for every process running. We have done that in the AX one. So simple code, same set of P functions. Oh, it's buffered output, by the way. So as you write your JSON records, they all go into a big buffer in memory, and then it does a single write out in one go at the end, so that all the data will get to the other end, the injector or into the file in one chunk. So that helps synchronization. Most of the data in NJMON for AX comes from the libperstat library. It's nice and clean. The Linux is so far behind, it's embarrassing. Okay, so we now, with both of these, we have hundreds of stats rather than the basic set that nmon was actually gathering. On the AX side, of course, the VO server is AX 6 or 7, depending if you're running VO server 2 or 3. And we collect a load more stats from the virtual disks and virtual networks on the VO server if you want to switch those on and see how we're virtualizing your hardware. You can actually track all that as well. Okay, so NMON Chart, I released it here on Monday. Bit of a prototype. There's only 400 lines of code. There's about 12 lines of code per graph. I think I could just about halve that. I catch myself sort of duplicating a lot of code that I don't really need to, make it bigger, put it into a function and just call it with parameters. So we can actually reduce the 400 to maybe 100 lines of code. We added we would need to add some of the fancy graphs that NMON Chart has into NJMON Chart, but it gives you an idea of what it looks like. If you are thinking about using NJMON, but you just have a Python, a JSON file, you just want to have a quick look. Is it useful? Is it got some good stuff in it? Then we can use NJMON Chart to actually have a look at that. And it works the same way. Use the NMON Chart, the JSON file, and it'll output this HTML file like this. Okay. And of course, you can automate this and cover hundreds of files and generate all the data. Over on the right, I've got the 24 first graphs we've got running. And this is what it looks like. In actual fact, I think I've got, yep, demonstration 2. So let's have a little go at that now. Come back to my applications, Chrome. Okay. Yep, there we go. Right, okay. So here we go.
Yes, I can see that, Nigel.
And you can see that.
Just a reminder to everyone, if you've got questions, post them into the chat window.
Okay, so yeah, so yeah, all the buttons are red color, so I've got to fix that. But you just go in here and click on the button, and we got this is the VP entitlement and CPUs used. You can see this looks very square in here, and so yeah, I realized that when we were saving floating point numbers, we were only using one decimal point, 1.1 digit after the decimal point, and so that should be all rounded off for the next version when I compile it up and add it to my machines. This is the nominal frequency and the actual current frequency. You can see 3.9. This is a bit embarrassing on AIX. We don't report the actual current frequency very well. Not even NMON. NMON will get an upgrade in December for versions of AIX coming out after that, but that's a bit embarrassing at the moment. We've got the physical CPU use. You can see the user system wait and idle, as you might expect. We can do some drilling in things in here, and drill in further again. See the details. We do a right click and come back out. So all this works as it does with the NMON chart, because I'm using the same framework in here. Run queue. You can see those are a little bit blocky in some places. Process switches, system calls, read-write functions. Oh, we can see, look, there's a great big spike in there. Again, if we draw it without that, we can actually see some of the more details. Forking exec, similar sort of thing. Oh, look, so here's something. Interrupts. This is a LPAR, virtual machine. You can see it has lots of virtual devices, and I was wondering, what does it have? Physical device interrupts or soft interrupts coming from the hypervisor? Well, it turns out nearly all of it is the soft interrupts coming from the hypervisor. I've got load averages in here just because I could. Memory use, all the different memory statistics. The top one at the top is it's got 2 gig of RAM in this server called Silver 5. But put some more information. You can see in here, this is AIX, pretty recent. Came out week 38 of 2018. Just a little reminder up there for people to highlight how old their copy of AIX is. Might get them fixed. Here's another one. I just wonder what was happening really. In here, when the kernel passes a program a block of memory because it's asked on a malloc operation, give me some memory, it has to zero fill that memory. It can't give you the memory with the old contents from the other process that used it last. And there's hardware support to actually zero the memory in here. So you can see there's some daemon going off zero filling memory in the background, I think. Paging space. This is a fairly simple machine, not doing very much. We've got here paging itself. We've got a little splurge of paging. Whoa, 30 pages a second. Not very much. We have disk stats in here. Again, we've got a little spike, something big happening here. We're using the iceberg in here. The reads are all 0. Everything it needs is in memory. It's occasionally writing little bits to the disk in this little example, and we've got network bytes as well in here. So we can see the data coming in and out. This is probably me logged in as a session running some tools. Of course, in here somewhere, if you look at these ones, yeah. Yeah, so this is NJMON's running in here, and look, used percentage 0 all the way across. It's using less than 1% of CPU time all the time when it kicks in once a minute. We've got some other things here, disk packets. So we'll improve this and match it against the NMON chart. Get the bubble charts of things working if you created the top process stats as well. Right, now I'm going to dive back to my screen here. Somebody confirm you can see my charts.
Yep, it's fine.
Excellent. Okay, great. Oh, click on the right window and then I should be able to move on. Okay, right, back to the main plot. Time series databases and real-time graphing. Okay, so what does an injector do? I've got these two covered. We load the JSON data into a dictionary and then adds each snapshot into a measure, and the measure is fired off to the database. So if you're not a Python or not even a programmer, you probably won't care in here, but we import the client for InfluxDB, and here's the name of the database. This is logging in to the database, so now we have a connection to it. It's preparing some data structures in here, and then this is the JSON data. And so for each sample, the snapshot from NMON, it picks out a sample host name and assigns it to variable, the date and time, and then it creates some fields. So in here it's looking at the CPU utilization numbers. In there are actually 4 values: the user, system, wait, and idle. and they're all just immediately copied across the fields. Then you create this data structure, which is another dictionary containing dictionaries, and then you append that to this data type called entry, so it's a list of dictionaries. And then at the end of the day, you run the points, the actual list of data structures, and they all go piling into the InfluxDB. If you're doing a bulk, you have an NMON file with 2,000 data points in it, and you want to pump them all in, then you do it in batch sort of mode. If you're doing it live, you've got it piped straight into the injector, then it will do it one per snapshot. So as a snapshot comes in, it pushes that straight onto the database because you want that on the screen as the next data point arriving on your graph. Okay, so this is looking at my infrastructure diagrams. You can capture NMON data locally and maybe over NFS, send that to your admin machine. We could use FTP or SecurityP or even Secure CP. A copy to actually move the JSON file over here when you're done, or regular intervals. Then there's the socket way, so you're actually on this machine and we use the SSH command to get to the target machine, run NJMON, and use a socket to get the data back so the JSON file appears on this machine. Or in this case, we're using SSH, gets the data back down the socket, and we just pipe it into the injector. Now the injector is fairly small, actually it's got smaller than that now. Loads it into the, in our case, InfluxDB, and then you look at it with Grafana on your web browser. Of course, this could be your whatever database you want. By the way, the JSON files, they do get quite big compared to good old NMON, but they do compress. If you have 32 megabyte file and you compress it just to gzip or something simple, 32 megabytes goes to 1 megabyte, so it saves a lot of space when you're actually storing these things on your disk. Okay, so let's look at this is similar sort of diagram in here that's pointing out you could inject into Splunk or Logstash to use the ELK tools. Another one I've been asked for is Kafka. It's an Apache service that is used to handle we jokingly call it, if you want to suck the internet, if you want to have lots of streaming data across your network, but trying to analyze what's going on for intrusion or illegal things happening on the network or whatever happens, you're doing it, you can use Kafka. It will watch the data going past and pick out the bits it thinks are interesting. So I've been asked, does NJMON support that? And the answer is I've no idea. If you're a Kafka expert, tell me. So here's the new collector down the bottom, though. In this case, the initiator is NJMON. You give it an IP or a host name and a port, and it creates a socket to the new collector. There's a dotted line here. It saves the JSON file anyway, and it will also inject it into your database of choice. So plenty of different ways of getting the data from your target to your source. And if one of these doesn't work, well, all right, give you an idea what you're thinking, and maybe we'll put that in as well. This is just highlighting the commands you'd run to start the collector and the port number, for example, and you have to match that over here when you're actually running NMON and have the same secret. And you can put it in cron, for example, so you kick off a new NJMON at midnight, and then you're set up in here. Yeah, once a minute for 1440. That's once a minute for a day, and then it'll start a new one the next following day. That's good because if you reboot the machine, well, by midnight it will actually start collecting more data again if you forget to do that yourself. Okay. Yep, and if you've got the -i in there, and then it'll actually do the injecting as well. Right, now here's the tricky one. Okay, let's try and demonstrate creating these graphs. Now, I am not an expert on this, so somebody confirm that you're looking at Chrome.
Yes.
Yep.
And we'll go back in here now. Jyoti and Gareth say that they like the black one more than the white one, or at least in the WebEx. So we'll start in here. You see, this is my template for this experimental one in here. I've told you about some of the things we can do. We can also do things like, let's have a look at this simpler one in here. I have a Raspberry Pi with 5 temperature probes, and I changed it generates a web page with the numbers in, but now I just added a couple of lines of Python in there, and it now puts it into my database. And so here are the temperatures in my computer room. This is the last 24 hours. I don't know how many days worth of data I've got in here. Yeah, there we go. Here's the last month, and you can see the temperatures going up and down in here. Yeah, so this is our air conditioning unit failed, and whoa, the temperature went up from 12 to 22 centigrade in our computer room. So it's just using this to show you some of the features we got in here. And you can, if you've got any other data you have, as well as NJMON, application data, transactions per second on your database, number of users logged in, number of batch reports ran, or I was thinking you could actually measure when your batch job starts and stops, and you could have a step graph appearing. The batch started running at 3 o'clock in the morning, and it ran till 4:44 or something, and you can see if that's changing over time and getting longer and things like that. But anyway, in here I'm going to actually throw this one away. Yeah, so go to create. Do you want to save that? No, I've already got that saved. So in here, actually want to start over here, add a panel. And that's where I am, right. Okay, so I'm going to start from scratch, say that I have got no idea about my nmon data. Graph looks good, doesn't it? You've got the text field. I had some of those for sort of single stats, rather. I had some of those. I've added, this can be bigger, added pie chart and clock. They're two add-in plugins that I've been using. We can have this alert list so that it changes color if you go over thresholds and things. But let's just do a straight graph in here. And oh, there it is. Just grab some random data. That looks like the share price of Intel. Okay, so let's go and make this more interesting, shall we? Takes a while. Underneath things, there are things going on in here, so I can remove the graph, or I can edit it, edit the content. So I want to go and have a look at how busy a machine's CPUs are. So I'm going to go in here, and it says the data source. I could set the data source to this, but here's my nmon. This is for nmon version 14 in here. So it knows where to get the data from. It says, yeah, but what do you which measure do you want? So you've got loads and loads of them in here. And I'm looking for total. It's going to be down the bottom, isn't it? Well, you can just type total logical. Okay, there it is, total logical CPU. And then it says, okay, well, that's the thing you want. Where do you want it from? So in here, these are the things that I've put in when I inject into the InfluxDB or any other suitable tool. I've got the host name. I've got the MTM, that's the machine type model, like an S924, for example, or E980. Which operating system is installed, and the serial number. This would allow me to look at all the LPARs or virtual machines on a particular machine, because the serial number is unique. But let's just do it by host, and we're going to select it in here, and we'll go for Silver 5, and that's got some data. So, okay, so that's the what do you want now? In that record, the logical CPU, we have a user, system, idle, and wait. So let's pick up user. And I'll just type in, oh, you can see it's already doing something up in here. And I want to give that a name. It said it's taking the mean of the total logical CPUs, but this is the user in here. Oh, I'll put a percent sign at the end. And I click somewhere else. Yep, it's changed it up in here already. Now there's 4 numbers in here, so I need to do this for 4 times, but I can just go in here and say duplicate, duplicate, and duplicate, and then I can go down in here and say this is the system, and this is the weight. Wait, don't be nice if I spelt it right. I'm famous for not having the right. Open D here. This has been put away. We'll open it up. This is the idle, isn't it? Idle. No. Idle. Okay. Now we can click and here exit. We can go back in here to go back to the graph. So here's our graph. I'm not quite sure why that is sketchy like that. That's new to me. Anyway, panel title's not very interesting, is it? So let's go back in here to edit it. It's under General, Panel Title, and we can say Silver Logical CPU. And come back. That's that fixed in there. It's actually doing something odd with these graphs. I'm not quite sure what's going on there. But anyway, if we go back into edit mode and display, we'll see we've got line graphs in here. Maybe it's the line width is a bit low. No, that's not helping. And we can say, tell it to add points. Whoa, the points are a bit too big. Take those down. That's better. And of course, these are adding up to 100%, but they're not stacked. So we'll stack them over here. And okay, so now we've got the data going up and down in here. Maybe, yep, that's enough for the things that we actually want to show you in this one. We can have, we can switch those off. Go for bar charts. Oh dear, that's not so good, is it? It's probably the number of data points, or it's something to do with it taking the means in here. You see this mean value in here. Could fiddle about with that a little bit and get them looking like my other graphs. Okay. So that's giving you a feel for how quick it is to do these sorts of operations here. I'm just checking my list of things to do. Okay, now I did that really quickly because of that duplicate feature that I decided to use. Now you can quickly move these things around. I've seen people on websites that you meant to make them like thirds or quarters and halves and things like that, and they tell you to have one of these that's down here and half hidden to excite people to scroll down and have a look at the other graphs, for example. Okay. I'm babbling here now. We have, oh yes, we've got 125 for a percentage. That's not going to work, is it? So if we look at axis in here, the Y, which is on the left, isn't it? So that's a minimum of 0 and a maximum of, I found it's best to put about 105 in here. Because sometimes with rounding errors, it can go to like 101 and it will then not show you the point. It looks like there's gaps going across the top. But okay, that's okay. And the display, it's definitely got the highlight lines in there. Okay.
There's a suggestion to try bars, Nigel.
Okay. Yeah, I did that. Let's change the data down here. There we go. That's looking different. Now, what is worrying about is that these are, well, let's drag this up. These are all data points, really, aren't they? So in between the data points, it's not quite sure what's going on. So it's trying to average those things out. And sometimes it actually tries to show you the nulls in between the points, and sometimes it doesn't. So we're looking okay there now. If I switch off the points, then it will look like some of the other graphs we've seen. Didn't work, did it? Okay, all right, I'll do. Right, now on this one in here, I have this means in here of switching between machines. Silver 5 and things in here. I told you about changing the colors. That was surprisingly easy. Same sort of things going on in here. We haven't got much system time in here, have we? So how do we add that to this feature in here? It took me like half a day to work that out, and there's a slide in the deck that tries to explain how to do this. So we'll just give that a go now. So we go in here, settings, and we have a thing called variables over here. And so there's no variables yet, so we'll add one. Now this is where I'm going to type in something that's not going to work very well. So I'll try and do what I've done in the past. In here, data source, I'm going to have to pick up Paragon. This silver one, this is my InfluxDB running on power. So it's happy that it's there. There's no data in it yet. Query. Now this is a bit odd. I just had to copy this from somewhere else. Show tag values with key. Didn't work, did it? Values with key equals host. So again, this is one of the tags that I use when I'm injecting the data and say this data is for this host name and it's an S924 and it's going AIX and it's on this machine with this machine number in here. Now this really is hieroglyphics. Don't ask me what this is about, but it works. Yep, I got it wrong. // Okay. Sort, we can go alphabetical ascending. And what really threw me is, you can see in here actually it's done all this. And so it's looked up for what hosts are available. And you can see actually it says down here, here's the list of all my host names. There's an add button just here. It was just bad luck that it was scrolled off. I do save and it just throws all this away. So I'm going to need to add this thing. And then we have a value in here. And now I can come out and we have it in here. And if I change it in here, it completely ignores it. Okay, so what am I doing there? What I need to do is now go back in here and edit my metrics. Scroll up in here. And instead of physically naming this thing in here, I can pick up this $host. So it's got slashes around it as well. So in each of these, I have to say, get the value from the variable that I'm setting with that pop down to get the data. Decide which machine to get the data from. So there we go. Now, do I feel lucky? Brass to silver 5. Yes. Now I don't know what she's doing down in here. The last 12 hours, 3 hours. No, it's getting worse. 7 days. Okay, so the graphs are working right. There's enough data in it. This is my outage when I forgot to run the data collectors over last weekend. Anyway, I think I can actually just drill it into here and to get that graph. So you can see I can flip between machines. Brass 6 is down. Silver 4. Is that running? Yep, that's running at 6.1, and I can flip to 3. Yep, that's running 7.1. Not doing very much on those other machines. I suffer with not having a nice busy server to have some interesting graphs. I have to write all sorts of cron jobs to try and keep the machine busy. Make the graphs look more interesting. That's another little project I'm working on. Okay, now I've got a friend working in a very big financial company in Germany, Sasha, and he's got one of these developed for Linux. This is, well, these ones in here, or the ones I was looking at earlier, this is for AIX, because the data from AIX and Linux are different. So you tend to really want a template for either a Linux data or for AIX data. Otherwise, some graphs may work, but a whole bunch of graphs don't work because the stats are named differently or grouped differently. And you may want to actually have a different database. So you have an AIX database and a Linux database to make it actually clear, so that these don't tell me the ones. Some of these in here, Silver 2, yeah, that's a Linux server. None of the stats match up. Oh, we can pick out an entitlement and how much memory it's got, but that's all we got. Oh, we actually got some down here. Oh, the frequency, the gigahertz rating is running in here. So I'll scroll down. This is interesting. Oh, something over here. Network. Yeah, well, that's probably the same stats for both. So that's another little area that we're improving, and we're going to produce templates of some of the data. We have somebody called Earl Jew in America, very, very advanced performance tuning for AIX. and he thinks like he likes to monitor the decrementer interrupts. And you think, what does that mean? But he can use that number to find out how efficiently AIX has been set up and is running on the computer. And if it's in the wrong ballpark, then he can definitely make your machine go faster, typically by removing virtual processors that you don't actually want, and making the LPAR run on fewer physical CPUs. Okay, I'm going to go back to our slides and finish off.
Yes, I can see that, Nigel.
Okay, right. So yeah, here's a list of. I'm going to quickly go through. Here's a list of the other databases. There's Prometheus, for example, if you wanted to have a bit of both. In here, this is how to create the graph, set the graph, what sort of thing to put in here. This is looking at run queue, just one graph, and here's an example of it. You've seen how to change the color. What color is a run queue? Does anybody know? We should have a debate about these things, shouldn't we? And have some sort of convention that we all sign up to. Okay. Some of the other data in here. And you've seen how we can slide graphs around and get them to fit as we wanted to. We've changed the it's auto scaling here, 1 to 25 and 1 to 2.5. The different things. Here's the two that I've added in, the clock and the pie charts. Pie charts particularly nice if you've got ratios of things like memory, which is free or used. As ideal, it always adds up to the same amount. Not so good for things that aren't open-ended things. Oh, here's my chart of what I've just gone through here and here. So, other stats. Yeah, I've showed you my Raspberry Pi temperature probes. There's an expert blog on how to set up the Raspberry Pi to do that. And you've seen the sort of graphs you can find. It's very nice when the temperature excursion happens and you can tell the guys, oh, it happened at 5:30 on Friday night. And they say, oh, yes, that's the time we were switching off some air conditioners and switched the other ones on to give them equal work over the year. And they switched off some, and the new ones didn't start up properly. So we can find out what caused the problem, as well as being worried about our machines overheating. There's an extract tool that I have. I think I've given a presentation here with Jyoti on that as well. It's using the HMC REST API to get stats. We've got temperatures for the smaller machines in here. We have the performance stats, a limited number of performance stats on the LPAR or server level that you can pull those off. That's the sort of thing that the LPAR to RRD tool gets, those sort of stats. And from the HMC, we can also get shared storage pool stats, which is just about the only way you can get those data off the entire shared storage pool. And I mentioned there's an nmon+JSON and there's an nmon+InfluxDB tools that we can use to go and get some of the older data and put them into these modern tools and graph them up and have a look. So some other wacky ideas. At the technical universities, there's a plan to run an NJMON hackathon. So that sounds like fun. We may just present you with a working system and let you design your own graphs or do whatever you like. If you're happy just taking a JSON file and using Python to generate something new or investigate things, that would be good. Tomorrow we're starting a project using nmon data or NJMON data with our artificial intelligence tools, Power AI and those sorts of things. Normally AI is used to look at unstructured data, web stats or images. An image to a computer just looks like a random bitmap, doesn't it? But it can find the data in those. But nmon and NJMON is highly structured data. I can tell you that it's that number there that's telling me that you've got your entitlement too low. So it's a rather different ballpark to some of the other AI tools, but I've got an AI expert working with me, and we're going to run a project on that shortly. NJMON is nice for that because a lot of the AI tools do their data investigation in Python, which now we can load up very fast, rather than having to do with a comma-separated, slightly odd format from nmon. Okay. Oh yes, this is a dream I have. nmon for AIX is proprietary code and it's locked away in the AIX labs, and I don't actually have access to the source code. So that's settled. We now have an NJMON for AIX. It's not a very big program, and if you want to go and get the data and do something else with it, that's up to you. Hopefully the JSON format will hit a lot of people's interest. Now on the Linux side, the nmon for Linux is open source, and I am in control of that. And now we have NJMON for Linux. So we actually have two different tools now. Now nmon has got quite popular. We're just about to hit the 700,000 downloads. Probably by the end of today, actually. I should have taken you to have a look. And two tools, then you'd have to install two different tools. And people do actually upgrade nmon over time. It really annoys me when they send me nmon data from like a 7-year-old copy of nmon running in a 1-year-old copy of the operating system, but that's my problem. But I could put the NJMON code inside nmon, and then depending on the parameters you type in, it either runs nmon mode or NJMON mode. Have two main functions inside there, and we work out which one we want to actually execute. A very quick way we can do that, in the sort of Unix dirty tricks department, is you have the one binary but has two names in user bin, and depending on the name it will behave differently, but it's actually one piece of code. You actually find Oracle does that because all the Oracle tools have all the Oracle libraries attached, so they actually make one binary, and depending on the name, it will be the SQL server, or we do the logging utility, because they have the same libraries. The idea being, if you only have one copy of those libraries in memory, and they all share it rather than having multiple copies. But we could do that later on. I'm going to wait for NJMON code to settle down. We're still sort of in a development phase. I've just found one set of the numbers is all full of zeros in some peculiar case, so I need to kind of fix that. But we're learning fast, and once that's settled down, maybe I'll pop that inside nmon. Then if you upgrade nmon, you'll get the NJMON functionality. And at the end of the day, it's very similar data, but it's in JSON format coming out of the tool. There's a lot more of it, actually. There's lots more stats in there. For nmon, I keep getting asked by the Linux guys, I want these 3 stats and I want those 5 stats. And I said, no, if I put those in the output file, I'm going to get 10,000 complaints. Anyway, so what next? Well, browse to tiny URL NJMON. Jody has told me that some people have TinyURL blocked from their work networks, so it's actually there. NJMON SourceForge and NJMON at the end. So you can download nmon for AIX, VO Server, or Linux, and the charter. The collector is a separate program, very small little program really. And the injector is 40 lines of Python for the 2 different tools. And if somebody's got ELK and can work out an injector for me, that would be very helpful to the community. And we've shared our first Grafana dashboard in there. I've got some friends working on others. We can update those and share our ideas about what they should look like. It's very nice to say, oh, look at that. How did he do that? And try and work out how. So one of them has graphs that you can sort of fold away with a little turnkey thing. So that's quite good. And they've got a list of the file systems across rather than graphs. But anyway, you have to decide your database tool and your graphic tool, or you can use InfluxDB and Grafana for just a prototype and throw it away when you decide what your tool is going to be. And then you're going to add NJMON to your virtual machines and VO servers and start taking data. Don't go too mad to start with. Once a minute, once every 30 seconds seems to be quite happy. I mean, you could go down to once every 5 seconds, but then if your InfluxDB machine is running too slowly, it will start getting behind. That's what I'm worried about, really. Oh, here's the nmon for Linux website, and here's the place to get all the information. There's a discussion about why NJMON. In red, these are the problems with nmon that we're trying to fix, and these are the new things that we have available to us. If you have a flavor of Linux in particular that's not supported, or have released a new copy of the code but haven't compiled it for you yet, you can do that yourself. Download the .c. There's only 3 files for the 3 tools. Install the GNU compiler, take about 2 minutes, and then this is the commands. The file input file and the output file. Use 04, that gets maximum optimization for a bit of a speed boost. If you're running VO server, well, you compile it on AX6 or AX7, and you add to the command line these minor D tools, and it brings in the extra stats. If you have these the extra code in and then run it on AX, it doesn't like it because it can't find half the stats it thinks you want. So there's with or without the VO server support. The injector and the charter, you just need Python. Very easy to install that on Linux. Some of them seem to just have it by default now. It's getting so popular. We actually have Python 3 on AOX now. I haven't actually tested that with my bits of Python, but provided I'm not using any strange libraries, that should work fine. Okay, if we have errors and problems, tough data, that's what I'm dealing with at the moment. It's nothing like drawing a graph and you get a whole bunch of zeros. You suddenly realize that isn't right. And you start looking back where the data came from and you say, oh yes, the data collector's got a typo in it there, and we've got to fix that. If you've got enhancements for the tool, the charting tool, for example, Injector for Elk, I mentioned that, other dashboards, let me know. The Grafana dashboards you can actually upload to Grafana. There's lots of samples there that you can look and maybe go and learn something from those. You can email me, that was on the front chart, or longer term, the Performance Tools Forum is where I hang out. Whenever anybody adds a question there, I get email and I'll get back to you pretty quickly. Yep, the other data sources, I mentioned these three, where to get them from, and a whole bunch of things at the bottom, transactions, log files, all sorts of things you may actually want to start bringing in. Then you can actually, for example, I can look at the temperature and look at the gigahertz rating, and if my machines were overheating because the air conditioning failed, I can actually see a correlation of the two, for example. Particularly with your applications, you want to track your applications as well as your CPUs and see if it's too many users or when you hit a particular transaction rate, things start going pear-shaped. You can pull all that together. Okay, this is just an example in here. Oh, this is nextract. So we've got the watts, the power the computer's using, my S924, with the performance of the machine, which is the gigahertz over here, and the temperature is shown at the machine. And you can see there's some sort of relationship here. These double hits in here are expressed down in here of run queues, and physical CPU is actually generating heat, and the CPUs are taking more electricity to actually run faster on the machine. Phew. Right, there we go, Jyoti.
Thank you so much, Nigel. I'll let you catch a breath. So before we take questions, I'm just going to tell people about the next session. So in February, on the 6th of February, we have Jesse Gorsinski talking about the wide world of open source with IBMI. So IBMI and open source, 6th of February, 2 o'clock UK time, so same time as today. And Jesse is the business architect of open source on IBMI, so he's the guru in this field, and you can see the details of what he's going to be talking about in the abstract on the wiki page, and I'll be sharing that when I send replay information for today's session as well. So if you are not registered, send me an email, and then I'll make sure that you get notification of any future sessions, and obviously the replay from today as well. Okay, there's quite a few questions on the chat and some comments. Can you see that?
All right, yes, I just got there.
Okay.
Go on, read one out, and I'll try and answer that.
Okay, just scrolling down. Hold on a sec. Right. Yeah, there was a question right at the beginning of where you were talking about something where somebody was asking whether it's Linux on Power or Linux in general, and Gareth already answered that. The particular comment was Linux in general, but
yep.
We are talking about Linux on Power in this particular session. What else? Another thing was, can we have real-time charts, something like a dashboard of real-time monitoring for system administrators?
Yeah, this is real-time. Up in the top right-hand corner, there's like a little yin-yang sign, two arrows touching each other's tails. That will do an update of the screen, yeah, but it will actually move the graph across as it goes. Now, I'm only collecting data once a minute, so once a minute it will move across an extra. It'll be a couple of pixels on the screen. If you were capturing data faster, then you'd see them moving. I don't think we can go down to once a second or something. You need nmon and cursors to cope with the bandwidth to do that. But it is real time. If you're doing every 5 or 10 seconds or something, you'd be able to see it moving across. It can get quite annoying, can't it, though? That's the downside. If you're trying to say, is that 50 or 60, and then it all moves across slightly, then you can go nuts. But then you can change the scaling, can't you? So you can look at a day's worth of data, then it won't be moving so fast. So you can do that, yes. So they're all live, is the answer to the question. Next.
Yeah, there's a couple of comments saying this is great. So they like what they see, which is always good. So yeah, if anyone has any particular comments about what they've seen, then just add them to the chat window. It'd be good to get some feedback. Somebody saying, please take care how this is all configured. Gareth pointed out that where there was a version 4 at the top of the screen, you would not talk about AIX version 4 is version 4 of the actual NJMON.
It's the template version.
Question, are the Grafana NJMON graphics templates publicly available?
Yes, that's on the nmon for Linux website, but we'll try and push them into Grafana's got a list of them as well. So once I worked out how to do that, I'll put them up there as well. I'd like to make one that has all the LPARs of a particular machine, and we could flip the serial number to look at 2 different machines, for example. That'd be very interesting to see. Okay, which LPAR is making this machine really go slowly, for example?
Right. Another question, can you view multiple hosts in the same window?
Yeah, yes, you could have a sort of left-hand and right-hand screens being the application server and the database, and you just select a different host to do that. But you could create a variable that says, the DB host and the application host, and select 2 different machines to do that. And then you could dynamically change them on the screen. It's all there. Whatever you want, you can do at the same time.
Yeah, it seems highly customizable. Okay, another question was, why not use Docker images for Grafana, PPC64, or Little Endian?
Yes. Now, I'm a power guy. Now, I found a power Docker image available, but it was like quite an old version of InfluxDB. And so I didn't really want to do that. And I'm only just getting into all this Docker stuff. My little old Intel machines, well, they may be up to running Docker, but again, I don't want to teach myself Docker and InfluxDB at the same time. But that is, broadly speaking, where a lot of the industry is going, isn't it? So you just pull down a Docker image and boot it up, and we can have it already plugged in, ready to go to load your first NJMON script with the injectors all ready to go, sort of thing. So we could provide that as a turnkey solution in the future. I'm actually on a course on the IBM Cloud Private, which is all about Docker images, and containers. So give me a month, I'll catch up, and we'll have a go at that. But yes, it can be done. That saves an awful lot of fiddling about downloading. But then it was 6 minutes to download everything and get it running. So okay, Docker could do it in 6 seconds, but up to you. Horses for courses.
There was a question about, is the secret, I think where you're talking about passwords, is it encrypted for the socket communication, or can you see it in the clear with the sniffer?
Yes, I dodged that one. The answer is it's lightly encrypted. So if you're on the network, you'll see this packet going back, and you won't make any head nor tail of what's going on. And in there, it has the host of the machine that NJMON is running on, some other bits and pieces, and the secret in the first block when it makes the connection. If you look at the code, how we actually encrypt it is actually built into that, so it's not that secret. Again, I don't want to boil the ocean doing that. If you're worried about that, the data is actually only clear. I don't think performance data is particularly critical for keeping it secret, because this is probably inside the computer room behind the firewall. You can, of course, if you've got SSH, you want to use that method of connecting to the target machines, then that will be 100% locked down encrypted. So it's whatever you want to do, really.
Thank you.
You've got to remember that the NJMON is written in C, and I don't really want to rely on some great big complicated security package software at the moment. It's just a very simple, straightforward C. No libraries are required, apart from the libc, to actually run the binary.
Okay, we are running a little bit over time, but there's a few more questions, so I'll continue to the end of those, and then we'll stop the recording and stay on for a couple more minutes.
Okay.
Do we have source code or package for CentOS for InfluxDB or Grafana?
Yep, you go to the influxdata.com or grafana.com, and they have CentOS packages there. Firefox and not Firefox, Red Hat and CentOS, same package. You can install those current versions. Everything is perfect. Yeah. Okay.
There's a comment that this time slot for this webinar works well for the US West Coast.
Yeah.
I understand that. I'm going to try and vary the time of future webinars, but it's really difficult because we have people listening in or joining us from all corners of the world, so it's hard to find slots that are suitable for everyone. But I shall do my best to vary it a little. Are there templates available for your graphs?
The one we're looking at today, yep, I uploaded that to the NMON website, and so that one's there. My friend who does some clever things, I'll work out how he does it. I'll check with him. He's happy with me sharing that. He's done the Linux template, so we'll increase those. And this is the sort of area where we could do some user support. We'll supply a bunch of them to get you going. There's a few of the nice ideas built in, a few pie charts and those sorts of things. We've also got donut charts as well. They look nice. And there's also this heat map that's in there as well. If you've got 200 disks, a heat map is a way to find your hot disk out of whole hundreds of them. You can't draw 100 lines on a graph and work out what's going on, but a heat map will pick out the hot disks very quickly. But yeah, again, we should be sharing these things. Of course, if you're running Elk or Splunk, then they've got their own templates for their own graphs. And again, if anybody's using those, let us know and share them out. We can all help each other.
Great. Have you used alerts triggers in Grafana? Does it work well?
Haven't tried that yet. I have no reason to assume it doesn't work. I've seen examples of it flashing it has like a green heart for good and a broken flashing red heart. If there's something going on in here. At the bottom there's a question at the CentOS for PowerPC. No, I haven't seen that. Once you work for InfluxDB, once you find the place to instructions on how to build it, it's not too bad. But I hope to document that for Ubuntu, and it'll be much the same with CentOS for PowerPC. You have to get the Go compiler, a very recent Go compiler, and then you download the open source code and just tell it to go build or something, and off it goes and builds itself. And that'll give you the two binaries. I haven't got through the making it into a distributable package, because that has to download a whole lot of package making pieces of software as well. But it would be nice to other people help me out here. I can't boil the ocean, guys. Right?
Well, I think I should stop the recording. I just want to thank you very much, Nigel, for the session. It was a very detailed walkthrough, and there's some great feedback in the chat window that you can probably see. So
yeah, thanks for that.
Again, I'm going to stop the recording, and we can stay on for a couple more minutes. Thanks, everyone, for joining.
Goodbye.